Right, okay. I'll introduce myself just as a quickie. I've been with the Guild for probably 20 plus years now. Done a number of, spent time as area rep and quite a bit of time on the tech committee now as well. I've got a background of basic engineering, um, used to working with soldering irons, done a lot of track work, basic wiring, some kit building. I wouldn't put myself at the high end of technical side of that, but general kit building, plastic kits, brass kits, that sort of thing. And also doing sorts of general chassis construction. I'll keep it simple at that point.
Phil, unfortunately you've jumped in too soon.
Oh, did I? Sorry.
Yes.
Can
you put yourself on mute? Can you put yourself on mute?
Right. Okay.
Right. Now, James, you need to be on mute, I think, as well at the moment. So that right. Well, it should pick me up now as a central character, but it doesn't seem to be doing. Is there any reason for that, James? No?
Are you trying to pin the video or highlight it?
I'm trying to make a start. Right.
You're loud and clear, Tommy.
Right, okay. Well, good afternoon, everybody. We'll try again. Welcome to this afternoon's meeting with the technical committee. Before we start, we found this morning that we've got quite a lot of people in the session, so everybody's automatically muted when they join. It's to stop people talking over each other and to stop background noises getting too loud. So we're also recording this, which means that we'd like the speaker, who at the moment is me, to be on the large screen. Now, if you don't know how to do that, I'm just going to, if you look in the top right hand corner of your screens, if you look in the top right hand corner, there's a speaker view, and if you click on that, there's a gallery view. Now, for some reason, I'm not sure just what's going on here, but it's not picking up for me that I'm the speaker. Is it for anybody else? If we move to the speaker view, it's picking up Mr. Stubbs as Tim Stubbs as the speaker.
It's working okay on my system, Tommy.
Right, so you can see me, can you?
Does that pick up for me? I'm unmuted for a minute, Tommy.
Yes, yeah, that's picking you up, but for some reason it's not highlighting me.
It is on our screen, Tommy.
Right. Oh, right. Well, in that case, we'll move on then for now. But you need to be in speaker view. Right. So you should have me as the biggest image. Now then, during this session, we're going to, if you want to ask a question, you will need the chat function. So at the bottom of your screen, you'll see there's a chat button. If you press on there, it opens a little box, and in the bottom, you can type in a question, which everybody will see. We will answer those hopefully one at a time as the session goes on. But first off, we need to get everything rolling. So, as I said already, first off, my name's Tommy Day. I'm acting chairman for this session. And we've got the presenters, James Aitken, Steve Hother, and Phil Reed. They're here to answer questions on 3D printing, laser cutting, and track making. And possibly they're also quite knowledgeable on DCC between them. So each one of them is going to have a little, I think they've written a little spiel about themselves. So if you want to, I will unmute James. James,
Yep.
okay. Would you like to introduce yourself?
Indeed, yeah. My name's James Aitken. I started an O-Gauge at the age of 16, scratch building my favourite vehicles from the Southern Railway. No groans, please. Over the years, I've built many Parkside, Slaters and Pico kits, leading on eventually to brass kits of locos and wagons from various manufacturers. I became involved with the Guild first as a volunteer on the web team, then as an area rep, and now as technical committee chairman. I've made many friends in the Guild and hugely expanded my enjoyment of the hobby. I like to push the boundaries of what can be done with O-Gauge, using 3D printing and laser cutting to make my buildings, wagons, and lately locos too. I think we're in an extremely exciting time in O-Gauge. The increase in ready-to-run models of great quality and low prices means that this scale will be available to a much wider audience. I see my role as providing the information to this new audience so they can make the most of what is available to them in this fabulous scale. Thank you.
Thanks, Steve. James, sorry. Steve, would you like to introduce yourself? I've just asked to unmute you.
Right. I think I've unmuted myself. Can someone hear me?
Yep.
I'm Steve.
Yes.
I've been an O-Gauge modeler for many more years than I care to remember. I started with Formby clockwork at the age of about 8, 9, not sure when. Had a break soon after university, but to me the fun is making things, and an hour in the workshop at night was always my relaxation after work. I'm a retired professional railwayman, and there's at least 2 names on there who I came across during my work. You may have seen I did a video on DCC, which is available on the virtual exhibition, partly to try and explain the basics of DCC as it applies to O-Gauge, or those who've not encountered it, and to show some of the sound effects that are possible, because to me sound is the icing on the cake with DCC. It brings a whole new dimension to the hobby, provided you get it right. And I've seen lots of exhibitions with steam locos chuffing away and not moving, which rather spoils it. So I'm happy to talk about the videos. I build all my own locos in stock and track, and I'll contribute as and when I think I have something to add.
Thank you, Phil.
Steve.
James. Steve. Oh dear, I've got so many images up here. Phil, would you like to introduce yourself again now?
Yeah, I will. Yeah. Right. Do I put your finger on? You can see a full screen, me, can you? Right. Okay.
Yes.
Right. Okay. I first took on the role of first joined in the O-Gauge probably 25 years ago now. My background is basic engineering. I've done soldering work, track laying, layout building, basic wiring, a bit of DCC. So quite a lot of kit building in my time, and a little bit of chassis construction, simple chassis construction, and spent a lot of time as an area representative for the Guild, doing various shows around the country, demonstrating simple building methods to as many people as I possibly can. Obviously, for this evening's efforts, I will be concentrating on track building. So if you have any questions, obviously they will come up at some point. And I do also have a slide presentation to put forward to give you a bit of a background on what we can be looking at in the way of building track. Back to you, Tommy.
Thank you, Phil. Well, we've already got one question come in before we throw any more open. I'll read it. It's from Arthur. Hi everyone, thanks for all the great videos and demos. 2 questions. Will they be added to the Gauge Your Guild library site? Yes, they will. I think everybody's given permission for them to be added to onto the site. And for Romy, what was the sanding disc that you mentioned? Was it Abradisc used for filing down the oversized tabs? I think that's actually a question for me. Yes, there are Abradiscs. If you look on the do a search on Abradisc, they're a brilliant little piece of tool, as you obviously saw on the web on the film. Okay, right. So it's really over to you, gentlemen. I'm looking to see if there's any questions come up. There are no more questions. So James, would you like to explain something about 3D printing and laser cutting? Are you okay with that? Oops.
Yes, indeed, that's fine. I do have something I can show. So if you would like to make me a co-host, please, Tommy.
Right, participants. Oh, I can do that from, where are we?
My picture.
Make you co-host. What's your name again?
James, generally. Could be Steve or Bill.
There you go. You should be a co-host now.
Lovely, great, okay. Okay, so I hope you can see this. This is a little presentation on laser cutting. Can you put your thumbs up or something to say that you can see this? Fantastic, brilliant. Okay, great.
Can you go full screen so we see the central image?
Yes, indeed, I can do that. Wait a minute. I would be if I could actually get to my PowerPoint. Where is it? Right. Animation slideshow, there we are. I just need to run it from current slide. There you go. Right, I'm there. Okay, so this is our laser cutter. This is, I belong to the Risborough District Model Railway Club, and we decided that we would buy a laser cutter for ourselves, mainly to build all the buildings we wanted for our 2 layouts that we're putting together. And it meant that we were able to produce all our buildings cheaper than we could do by getting them done professionally. But also it allowed us to learn all these new techniques of 2D CAD and the whole process of making such a thing. The actual laser cutter itself has a head. Key features of the laser cutter are that you focus the beam onto the top of the material. You can adjust the speed of the cut. So if the head is moving very quickly across the material, it doesn't cut through, it simply scores. And you can adjust the power. So in this way, you can make changes. You can form different effects on the material that you're dealing with. You need to be able to draw the required drawing, and you need to be able to export that in a format called DXF, which is drawing exchange format. And all these programs, AutoCAD, TurboCAD, will all produce these. And the software that comes with the laser cutter will also do a certain amount of work for you. It will eliminate duplicate lines, and you can determine the order in which the cuts happen. Materials we use are ply, MDF of different thicknesses, Perspex and acrylic. They cut extremely well. And a material called Romark, which is a mixture of ABS and acrylic. Paper and card, color laminates. You cannot use plastic card in this machine because when it cuts, it gives off noxious fumes. I've also found a problem with ABS in that ABS will cut, but as soon as the beam has passed the cut position, it simply welds itself back together again. So it doesn't do a lot of good. Our machine will cut to 10 millimeters thickness, which is pretty phenomenal. You can produce plates such as we produce all of our competition badges and stickers. We can produce special effects. You can download bitmap images. So this is an example of something that we can do. This is a picture of the front edge of a platform. And here you can see on the drawing the stonework that's produced in the bottom half of the drawing. That's a bitmap. And above that are the lines that form the actual brickwork itself. So here with the horizontal red lines, they will be score marks and they form the horizontal mortar courses, and the vertical green lines form the vertical mortar courses. For producing things like windows and door reveals, we found that one technique is that if you've got, as you imagine, if you've got a cutout in a brick building, the window is set behind the first layer of brickwork, and you need to have, when you cut out the hole for the window, you really need to have the score marks for the brickwork mortar courses going through that cut. And we found we can do that using tiny little holes drilled by the laser at the end of each mortar line. I can kind of show you on the drawing here what I mean. So there's the side of a typical small hut. The blue line is then the cutout for the window itself. And then on top of that, we overlay tiny little holes. The little yellow dots are in fact little circles. You can see how small they are. And the effect of that is that the laser will simply spend enough time at that position to burn a line through the material and produces a little slot in effect. One of the problems with laser cutting is you often find, if you're doing very thin window bars, that having cut one square out, that material gets heated up to the extent that when you cut the adjacent hole out, the window bar will bend. But if you cut all the blue ones out first, they cool down sufficiently, you can cut the red ones out and you don't get the bending. So we've learned lots of techniques for improving the way we do things. This is a video of a laser cutter. I don't think I'll show that today. The laser cutter is a tool. Use it for things it's good at. Remember your basic modeling skills. You can carry on using a knife. And balance the time you need to draw and then cut against just making it using a knife and a piece of material. And here we have some examples of laser cut buildings. A lot of the material here has been cut out on the laser. All the brickwork. This is a 4mm model of High Wycombe. The fencing, again, that's all been done on the laser as well, including the posts. They were cut out of thicker material. And here we have, this is an N gauge model. The side of the building, you can see the incredibly complex brickwork pattern that was produced on the laser cutter. The sort of diamond pattern, the my fellow modeler models Dutch N gauge. And this, once again, all these components are cut out and the different layers are also cut out on the laser cutter. You can produce some extraordinary effects just by thinking ahead and deciding how you're going to design it. These plants were cut out of paper, coloured paper. So once again, an interesting thing to use the machine for. This is a O-gauge truck. It's actually a military vehicle, an airfix kit, and that was modified by changing some of the rear panels, which again were cut out on the laser cutter, then inserted into the kit. An O-gauge coach with laser cut sides, a commercial roof, ends and bogies. Very good for the sort of flat-sided coaches. And of course, if you're doing more complex coach side, you know, with paneling, that would be very easy to do on the laser cutter. This is a model of mine. It's a O-gauge Southern Railway Crocodile. That's got a complete laser cut body. All the bracketing, all the riveting is all done on the laser cutter. That's some of the detail on the side. The bigger rivets on the main panel, they were actually all individual rivets that I bought on a sprue and inserted one by one. You can imagine that took quite a while. The drawing process, this is the sort of typical type of drawing that you would produce. And here you see floor of a wagon, the sides, the ends, springs, etc. And that's the sort of thing that it produces when you've assembled it all. This is cut out of Romark. It's a white plastic. It glues together with plastic weld. 3D printing. Here we have examples of building components that have been 3D printed. The whole of the front, the columns, and the arch, all done in that. And here's some examples on that I've done: buffer body, axle box, and brake lever guides. Okay, I hope that was useful. I'll stop sharing now and go back to Tommy.
Well, thanks, James. That was brilliant. Steve, would you like to, I'll unmute you. Would you like to explain about your forte?
Right. Well, I don't know whether you've seen the video on DCC. I'll just highlight a couple of points. First of all, a typical steam loco installation. This is, now you have to guide me because I can't see myself. Whether can you see that now?
That's fine. That's fine.
Right, I'll hold it up. This is a chassis for an LNER N7 tank, built from an ACE kit. Really, I just want to show you how I fit sound. There's two important things in sound. One is you get the biggest speaker you can, and you must enclose the back, because sound, as you probably all know, is vibration of air. So if the back's open, you lose a lot of the sound. And the other thing is, if possible, is to get the speaker directly underneath the chimney. And of course, I should have said you need to drill the chimney out if it's a solid one. If you can do that, those two things, that makes a huge difference to the quality of the sound, regardless of what make of decoder or who's done the programming. So with this, sorry, my arm just slack. I'll just move my screen so you can probably, can you still see there?
Yeah, that's fine, Steve. Yeah.
Right. So I'll make this little plastic hard base, cut a big hole for the speaker. That's actually aldited in to make it soundproof. The backing box is a bit of a plastic drain pipe. Decoder on top, sorry, decoder on the bottom, and the stay alive capacitor on top. If you've seen the video, these have a big impact if you've got any dirty track. The demonstration I did on the video, I put a bit of newspaper on the track, and the loco at slow speed carried on for, I think it's 29 inches without picking up. So when you assemble the chassis into the body, you feed this into the smoke box and then put the chassis in, and that makes a big difference to the sound. Obviously, what I'm saying really only applies if you've scratch built or kit built your loco. If it's ready to run, you know, you've got what you've got and you've got the space you've got. The other thing I'm going to demonstrate, hopefully, is one of my locos that's sitting behind me. I'll get out of the way. This is DP2, which was a prototype diesel built in about 1962 or so by English Electric, when BR was looking for their standard Type 4, which of course eventually became the 47. This loco scratch built. This controller is a radio controller. Because my railway room is L-shaped, I work my layout on the basis that we have a signalman in the control panel, and each driver of a locomotive walks around with his controller and obeys the signals, or not in some cases. One driver actually got a Form 1, and he was a retired BR shedmaster. So because the room's L-shaped, we need radiator controllers so that the drivers, when they're out of direct sight and they don't want to be able to have a wire attached to them. This particular model is the ESU. It's unfortunately obsolete. There are various radio controllers available now. If you're thinking of buying one, draw a distinction between radio and infrared. Radio will go through brick. If I want to go downstairs, I can blow the horn from downstairs. Infrared has to have line of sight to the infrared receiver. It's a bit like a television remote. So if you want to go around the bend, don't go for infrared. So I'm now going to start the engine. So that was just button 8 on mine. And just blow the horns. And off you go. The wagons are all kit built, mostly from PRMRP, do quite a good range of air brake wagons. I'll just stop it because I don't know how much you can hear of me. I was saying the wagons are all kit built, mainly PRMRP kits, which are etched brass. They're a fairly old design, so they're not for beginners in etched brass. A couple of them are fiberglass mouldings, and I've built up a fairly decent length air brake freight train. Right, there's 2 questions on the screen. From James, do I use circular speakers or the rectangular ones? Most of mine on steam locos are circular, and all my locos except one have a 1-inch speaker. The one with a 3/4 inch was the first one I ever did, and I'd already built the loco and I couldn't squeeze a big one in. Some of the diesels have speakers of 40 or even about 70 millimeters, because you've got much more room in the middle of the loco pointing down. And there's a comment from Chris Walsh. If you have JMRI, you can use Wi-Fi and control the laptop wirelessly from your smartphone or tablet. Yes, I've seen it done at exhibitions. Personally, it doesn't interest me. I like the way we run my layout, and there's a couple of people on here who've been over and run it. We like to operate it realistically with a signalman and a driver on each one. But everyone's their liking. Yes, you can put it on the computer and you can sit back and watch the trains on. And Carl has said touch cap for lengths and ecosystems on Apple products. I gather there's all sorts of ranges. I'm a firm believer in KISS, keep it stupidly simple. So if it goes past the signal, you know who to blame, so you didn't stop it. Okay, that's all I've got, unless any other questions.
Well, shall we move on to Phil for now? We can have an open questions and answer session at the end, if that's all right.
I'll mute myself again.
Right.
Right, okie dokie.
Okay, Phil.
Yeah, okay, right. I'm just going to go and put my glasses on so I can see what I'm doing. Right. Right, have I switched myself off again?
No, 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 you're that.
Right. Right, I'm just trying to share the screen. This is host disabled participant. Tommy, you have to get us so I can co-host.
Oh, of course I do, yes. Where are we? Phil Reid, I will make you a co-host.
Good. Right.
Okay, you should be a co-host now.
Right, okay. We can share on that. Let's go back up the top. Oh, that's it, track building. Right, okay. Obviously for today I've decided that we'll be taking a look at track, and one of the biggest questions I always get asked is where do you start? And it is a bit of a minefield. So I always say to people, do your homework. Most of the fledgling railway companies would start using materials from external contractors to construct their railways, but as their railway network grows, the economy of in-house manufacturing becomes more apparent, and in time finding railway companies names on actual railway chairs. So obviously each railway company, obviously I've got a 3-bolt chair which I'm showing here, which is part of the national network. Each railway company come up with its own design. Obviously ballhead was probably more predominant in the UK, whereas if you went the other side of into the States and 1 or 2 other countries, they tended to start off with straight timbers and spikes and flat bottom rail. Geometry of track is another important feature that you must consider. Think about the type of rolling stock you'll be using on the layout, how locomotive and rolling stock will actually react with each other. I wanted to do a little bit more on this, but I actually ran out of time. But if you imagine a long wheelbase wagon, which is only a 4-wheeler, where you've got significant overhang at either end, when you're propelling a vehicle of this type through point work of any particular radius, it reacts differently with another type of stock, which has either got a longer or a shorter wheelbase. And as a result, you wind up with that dreaded pain in the backside, buffer locking. That's something we can obviously talk about a bit later at some point. What sort of materials? Well, this is very much up to the modeler. In the early days, you used to have chairs with spikes. Latterly, we had copper clad. Today, we've got a range of timbers, plastic sleepers, and even flexi-track. Obviously, the rail now comes as a separate item, which obviously you can then manipulate in whatever manner you like. Oops. Obviously, for maintaining your gauge, we have roller gauges. They're obviously set up to different standards. And obviously, in the 7mm world, there's various groups who consider various gauges as being better than the others. The first ones in the game were scale 7 boys. We've also got people who've tried 31mm, 31.5, and some of them, the traditional one obviously is 32, which most people tend to go for. I always suggest that the first project should be either a test build of a point. I make no exception as a 4mm one, because that just happened to be handy for me to paste up, or build a length of track, which I've displayed as a bit of flexi track base there. All of these are good fun, just to have a crack at it, just to get the feel of what you're having to have a go at. Point switch blades. This is the fun bit, which people probably don't really understand at the end of the day, but it's all about getting a decent contact with your switch blades, i.e. so it gives you the route where the train goes. The back of the rail is machined or filed, depending on your method of manufacture, to different lengths in relationship to the curvature of the turnout. So an A tends to be a much tighter one, which is around either a 1.4 or a 1.5. A B will go up to potentially a B9, but you then get an overlap from around about B8 to a C8, and they go up to something like C10, which are the really long turnouts. Obviously the leading then is much greater, and then on the opposite side of the back of the rail you then have a lead in on the top edge which you machine, but you leave the foot of the rail which then supports on the slide chairs. Right, the V's and the common crossings. This is a piece of engineering which, if you get it wrong, you wind up with something that doesn't particularly run particularly well. Regarding the V's, I must admit in my early days, I always thought you needed to file both edges and have them actually pointing together with each other. I've noticed that actually the way to do it is actually to put a angle on one length of the rail and then file the opposite length of the rail in a similar manner, and then solder the two together so one leads into the other, and that gives you a nice strong V with plenty of support. Obviously the check rails, these usually work better if you actually get some form of jig to ensure that the rails align on the common crossing. This is where quite a lot of trouble occurs when points have been assembled and this area has not been done in advance, because obviously if you don't quite get it in line, then you do run into a few problems. Now I've included here some flat bottom track, plain track. This is a bit of a cross section of bits and pieces. This is obviously mainly here we're looking at flat bottom. You've got the different types of track. On the lower end here we've got a bit of Settle and Carlisle coming in with the track which is now welded rail, whereas the line coming in from Carnforth is still jointed track, and you can see that we've got fish plates on there which have been oiled. Normally you would think of 60-foot track panels, but track gets replaced over a period of time and bits fail, so you quite often wind up with all sorts of different lengths. So it's all worth remembering when you're actually constructing the layout that if you want to show the rail joints, they're not necessarily always going to be uniform. Switch blades. This is something, obviously, again, it's another photograph of a real bit of point work, which I think is probably a better way of showing it. This is a side-on set of switch blades for a normal standard turnout on the railway. Obviously, this is designed to mechanically operate the way the switch blades work. In our terms of the model railway world, there's various ways that different modelers actually produce these switchblade ends and the way they drive them. It can be anything from a copper clad strip where the rails have been simply soldered onto it, or you have wires on a strip, copper clad, a Paxolin strip which has not got any copper on it, but with some rivets or something similar. So everybody's got their own idea and their own ways of doing it. And I suspect this is something that you can have quite a conversation about, because it might be only a small amount of movement, there's still a minor amount of rotation. And quite often at exhibitions, you see a lot of people struggling with switchblades which have actually broken off their mountings. Looking at flat bottom track, this is much of our railway network today is absolutely smothered with the stuff. In model railway terms, it's not an easy one to work with because of the level of machining required, or filing, depending on which way you want to go about it, to create the V's and the common crossings and the switch blades, because there's a heck of a lot of material to machine off. And of course, with flat bottom rail, there is a huge amount of variation in the weight of rail. As I put on my notes here, you know, the big four railway companies started off using it, like the North Eastern had £100 rail, the Great Western had £9 rail. And this is really only the tip of the iceberg, because even today, you know, I've talked to 1 or 2 railway engineers and they've come back and said that there are some bits of the railway network which have got multiple weights of rail in place, and they have caused quite an engineering nightmare when it comes to replacing track when something fails. I was recently down at my local railway station and the current track there is £133 rail. This is an overview of some track being put together. one of the interesting things about track work, you would think it's all been built to a standard template, but really most of the track work in this day and age is designed to fit a location. And I always use sort of somewhere like Kyle of Kelsh as an example, where the platform roads are dead straight, but they then head into a cutting, which then heads off round to the left. And all the point work is actually designed into that cutting, which means it's all curved. So here you get a drawing of the layout you want to do. You then lay out the sleepers in relationship to where the V's and the common crossings go. And then you just literally build it up bit by bit. So you start off with your main running line, you then go for the common crossing, which is going to be your next starting point, and you build off of each bit and just gradually work your way over bit by bit. And obviously with butanone and things like that, you really need to give it a chance to dry off, because if you try to build too quickly, which you can do, you get a degree of creep where it hasn't properly dried. And I often recommend that you leave roller gauges on overnight, particularly with the common crossings, to compensate for any creep you might get in the glue in the solvent drying. Here we've got some point work which is being constructed. It shows you what you can do when you get carried away, and it shows you the flexibility of what can be achieved in relationship to whatever you want to build. There's a whole range of things here. I was going to put a few more notes on these. This is sort of showing off, I think. This is a grand bit of track work here, which shows you what you can do. And obviously bearing in mind the relationship to how vehicles react when they're going through point work. Here, I think, see whether people can spot the deliberate mistake. One of the things you need to look at here, sorry, I needed to rotate this. Wherever you've got a V, you'll have an opposing check rail. And I can point out on the one nearest this end here, the builder has actually forgotten to put a check rail in. It has been pointed out to him. And that is all. There you go, Tommy.
Right. Okay. Well, it's questions and answers time.
Yeah.
There's a question just come in from Jonathan.
Yeah.
Which is, I think, is for you, Phil.
Right.
What's the current convention of having a straight section of stop rail in the area of the flangeways on a common crossing?
The convention, right? Okay. Are we talking about the clearance on the check rails? I believe it's 1.75 mil for the standard 32 mil. That's the one I'm familiar with. Some of the finer scale ones probably work to a different standard, and I'm not going to jump in on that one because I haven't got these numbers written down in front of me. I'm assuming that's what it is.
I'm just wondering, Phil, if it's more from the point of view that, as you know, with a standard off-the-shelf Pico point,
yeah,
there's about a 3-inch section of straight track.
Oh, there is. Yeah, there is. It's around about 3 or 4 sleepers where you've got where the V is on the common crossing. You have, and it also applies to the switchblade end as well, whereas you actually keep the V actually straight and the rail straight, even if it's on a curved turnout. This actually aids the way that the vehicles actually run through the point work itself.
And has that always been the case in sort of if you're doing bullhead point?
I believe that to be the case, but I could probably be put right on that one or wrong on that one. I think there are some people out there where I have seen it where they've actually tried to curve it through. If they've managed to get it to work, hooray for them at the end of the day.
Thank you.
Yeah.
Okay. We've got a question from James for everyone. Is there a way to spring the built turnout rather than needing to use a point motor?
Ah, that's a good one. That is. I would say probably what you could probably get away with. Can you hear me, guys?
Yep.
Yep. What I'm thinking you probably could do is, my thinking goes, rather than actually using a physical spring, which you would find on the real railway network, they have quite a big old beast for that. Probably using a measured version of a bit of sprung steel wire, which you can then sort of allow a degree of springing in it, which should be just enough to overcome the rail, the actual points to move. But obviously the key to that is the weight of the rolling stock going over it, because if it's not heavy enough, it will effectively derail it. So it's worth thinking about the weight of the rolling stock versus the amount of spring that you can actually put against the switchblade to get the level of movement you actually require. Possibly the other way to do it is to do what they've got on the railway. Well, I don't know whether you've seen it, but they have like a trap at the side where the train goes over and it effectively locks the point in place. So if you have a little switch on the rail side, you could actually have it so it's motorized. So when it approaches the point, it actually drives it across, which perhaps is another way of doing it.
Okay.
Yeah.
Steve, you wanted to mention something. It's not really a question, but you wanted to mention something about raised check rails.
Yes, there was some discussion on the Love Lane question and answer this morning. It's clear, someone raised it, it's clear that people don't understand why we have them, so I just thought I'd come in. There's a particular problem with very shallow diamond crossings, and if you've got a pony truck, the gaps on both rails are opposite each other. So with shallow diamonds, it can be pot luck which way the pony goes, the right way or the wrong way. So soon after the end of steam, BR started using raised check rails, and this is the reason why 9Fs are now banned, because they've got flangeless wheels. And I found it very useful on my layout. I had a particular problem with a V2, but that's, type of loco is irrelevant. Key thing, it's a pony truck. If you raise the check rail in the vicinity of where the two gaps are opposite each other, then as the wheel goes across, the back of the flange hits the new check rail that little bit sooner than it otherwise would, and it stops it going the wrong way. So I've got a very shallow diamond, it's actually a single slip up there, where I've just soldered a bit of brass about one and about 1¼ millimeters on top, and it completely cured the problem I had, where in one direction the V2, the pony always went one way and the driving wheels the other. It's something that you don't see on many models. The only problem is you've got to be careful not to raise it too high, because someone bought a Loveless Deltic to try out, and the latest version has traction motors very low down, and they simply rode up on the raised check rail. So you've got to be a bit careful on that, but it can solve a lot of problems. That's all I wanted to say. Thanks, Tommy.
Okay, thanks, Steve. We've got one from Tim Stubbs, and this one is for you, Steve. At shows, I often see steam locos with the sound out of sync to the driving wheel rotation. How can this be avoided?
Possible.
Well, the simple way is just to set it up. Yes, you often see it. You need to spend a bit of time, and the instructions are different for different makes of decoder. So I can only speak for ESU, and I've got the odd soundtracks. But basically, you adjust two CVs, and if you don't know what they are, look at my video. I try to give a simple explanation. You then walk along the engine, and of course, with a two-cylinder loco, it should be 4 beats a rev, and three-cylinder it should be 6. You walk along the loco slow speed, going 1, 2, 3, 4, and see if the fourth one is at the same position of the wheels as the first one. And if it's not right, you adjust the CV and try again. And by the end of the day, you're doing this in your sleep. But it's well worth doing, because it ruins the sound effect. You've probably heard the phrase nodding donkey. Well, the original nodding donkey was an O-gauge modeler setting up a steam loco, not a pacer like everyone else calls them. It needs time, it needs patience, it needs reading the instructions. It's not difficult, just needs the will to do it, basically.
Okay, there's a comment from Jonathan Bushell which says one can also use a cam on the excuse me, on the axle, then linked to the decoder to physically synchronize the chuff.
Yes, the first locos I did, I had to do something very similar because they did not have synchronization. These were about 20 years ago. It's the original Soundtracks ones. I didn't actually use a cam. I actually machined annular grooves into the back of one of the driving wheels, filled them with Awaldite and sanded it smooth, then put an extra pickup. So as the pickup went from steel to Awaldite 4 times or 6 times a wheel revolution, that triggered the chuff. I don't think there's any makes of decoder that still need you to do that. I may be wrong there, but it's far simpler if it's built in. On my video, I think I demonstrated one that I set up some 5-6 years ago, and it's still perfectly all right, exactly synchronized. And of course, once you get to high speed, you can't tell whether it's perfectly synchronized or not. Yes, you can use a cam. You used to be able to buy ready-made cams you could put on the axle. It's a lot of hard work, and if you can do it electronically, I'd thoroughly recommend it.
Okay, Steve. Well, we haven't got any more questions at the moment. We've still got a little bit of time, so if you've got any questions that you want, you'd like to put to the panel, now's your chance. Otherwise, I'm going to pass back to James as to what we can do next, just for the last few minutes. James, I'm slope shouldering this.
Oh, thank you very much. That's very kind of you.
Oh.
Well, I can, let me have a look. It's just, I'll.
Oh, there are actually a couple of questions come in.
Oh, good. Phew, that's a relief.
Yeah, one for you, James. What type of 3D printer are you using?
Right. I generally get my 3D printed parts made by a mate of mine in the Risborough Model Railway Club. I do have a deposition type of 3D printer here, but it's very crude and it produces really quite poor quality parts. The best type, without a doubt, in terms of precision, surface finish, is a resin type of printer. Where I get them done, he has a Anycubic Proton, which is £200, which is a ridiculously cheap price. He's recently bought an Elgoo Mars, which has a bed of approximately the same size, and produces equally good parts. I mean, you're looking at a resolution of down to about 50 microns. And at that level, you really can't see under paint any of the layering. It's extremely good. The parts, because they're resin, you need to use something like super glue to fix them in place. But yeah, very, very amazingly good parts. I can show you some examples. There's one here. If I just put that in front of the camera, you can see the brake lever guide is actually a 3D printed part made on one of these resin printers, and that is tiny. You've even got you can even see the holes that were drilled in for the pins. I mean, for £200, the resin printer is just extraordinary. I hope that answers the question.
Yeah. Okay. Next, we've got a plug from the Gazette editor. It just says more features for the Gazette, please. So everybody's heard that, haven't they? Not just us.
I was particularly keen to get the message.
Okay, Philip.
You've got 27 people or something watching this. It's not just the committee I'm talking to. I like this stuff, and I think our readers do too. So let's keep it coming. Thanks for the plug.
Okay, Philip. Right, we've got one from Alan. I may have missed it, but do people use templates for points, or do they build on the baseboard? Philip?
Right. It's a bit of a mixed bag on this one. You can use, there's a range of ready-made templates which are available where you simply just build over them as a sort of a sacrificial arrangement. Or you've got the delights of Templot, if you understand it, where you can actually draw up whatever track layout you want. Or if you're not into Templot, quite a lot of people will draw stuff out freelance. Obviously, there's a bit of a game with that because you've obviously got to be careful about making sure you get the geometry correct so that the common crossings and the V's and everything line up where they should. But generally speaking, there are templates out there which are purchasable, which cover pretty much most of all the types of turnout, i.e., you know, normal standard straights, A4s, A5s up to B9s, but you've also got outside slips, double slips, single slips. And if you want to do a curved turnout, that's normally the party piece, because you would assume that a curved turnout is set, but it isn't. It's all more often not designed to fit a location. And I always suggest to them, and it's a shame I haven't got a picture to show it, so you have to sort of try and think what a point actually looks like. And you basically take a length, I take a length of rail, lay it out on the curve I want it to be, and then I take a straight template and cut it into strips and then lay it out along the curve. And I usually take one of the inside switchblade line that takes you through the common crossing and use a length of rail for that. And that usually works, but you start off with the biggest turnout you can lay your hands on and then work your way in. But you do find that you start off with something like a B9 and you'll wind up at a B7. And if you try to go any tighter, it gets so tight that you then have problems with the rolling stock actually going through the curve turnout safely. I think that hopefully answers it. Yeah.
Okay.
My own experience of track building, I use Templot and print it out on A3 sheets of paper. Stick the A3 sheets of paper together and build on a board. Don't build on the baseboard, because you're usually on the baseboard, you're in an inconvenient place and you can't reach. It's a lot better to build it on your desk where you can get to things easily, and you can, most particularly, you can get directly above it and look right down. And if you use double-sided sticky tape and make it narrow, 1/4 inch, no more sticky tape, put that down, stick your sleepers in place, and then start laying your rail on top of that. Because with the narrow double-sided tape, you can get the sleepers off without smashing it all apart.
Yes. Okay. Thank you, James. Keith has just put a comment, check rail on Pico track used outside on garden rail. Now, I'm not sure what that is, what question that is. I mean, the check rails on Pico track, they're standard, they're as they are. Shall I bring in, if I can find Keith to ask, to clarify that?
Yeah.
Okay, where are we? Keith, Gowan. Keith, I'm asking you to unmute so you could clarify your question.
Yeah, can you hear me now?
Yeah, we can hear you now, yes.
Yeah, I had a problem with the garden railway using Pico track and felt that the only way over it was to put a check rail in. And what I discovered was that if you cleared the Pico track underneath so that your sleepers were separate, and then with a spare sleeper chop off the chair, you could actually slide it under the Pico track and create a check rail for easy running. And I just thought you might be interested, because obviously a lot of people build their track with copper-clad sleepers, but there's also quite a few people use Pico, particularly outside.
Interesting.
Yeah. So a useful hint, useful tip. That. Thanks, Keith.
Okay.
If you could mute yourself again, please, Keith. This from James to everyone. Is there somewhere to get free or purchasable 3D print files for railways?
Must admit, I'm not aware of any at the moment.
Right.
Okay. I've just done a Google search on it actually, and I have come up with a couple of places. If you do a Google search on free 3D printer files for railways, it will come up with some sites, but you're looking at Thomas the Tank Engine type stuff.
Right. Okay. Well, we've come to the end of the session now. We've got one private question which we can answer if you're all right, Phil.
Yeah, that's
if
yeah.
you're all right with that.
Yeah, I was just
Go on, if you want to just ask it, and then we'll shut this down.
right. Okay, it was referring back to James's piece regarding building the track off the board, and that is just have to remember that the slide chairs, because they're in halves, you need to put a support underneath and usually tie it into a couple of the sleepers, so when you do lift it up, they don't just drop off into the ether.
Oh yes. Been there and done that.
I thought I'd just mention that because it was sort of it's one of those famous ones that easily gets missed.
Yeah, I super glue them on.
Oh, you do you?
Okay, gents. Well, everybody, I shouldn't just say gents, should I? Okay, everybody. Well, thanks for taking part in the session. I hope you've learned something from it. I will just put another plug in from Philip. Don't forget the Gazette always needs articles. And enjoy the rest of the show.
Right.
Okay?
Okay then.
Thank you very much.